exactly that's exactly how it works in nature, and that's exactly how it would work in farming or in precision agriculture, indoor growing. pH is the example that I think is the most prevalent environmental factor affecting microbial success. There's a salt concentration with nutrients and all the just conventional management practices, and pH is a big part of that also. pH actually is shown to predicate microbial diversity and community composition more than any other factor, being the strongest factor to manipulate microbial community structure across the world. And so you look at different conditions or different soil types, whatever, out of all the factors there might be, temperature, water, pH, others, pH is the first determining factor. And I think it's interesting for indoor growing because you can have pH shifts. You try to avoid that, but that happens. And so with functional redundancy, you have microbes that are able to persist and function through those shifts and kind of overall bridge a functional gap where a single microbe might work really well at a certain pH, let's say 7, but it might be very stressed at a pH of 5. And so that would not be the best microbe in that particular environment. And having another backup microbe that worked well across the range of that particular environmental threshold pH would serve the plant better.
That's really interesting. I think it's important for people to keep in mind that we tend to think in like black and white, but the reality of this, the complexity of the rhizosphere is that the soil may have a pH that we're getting, but like within that soil, there's all these little micro pockets where the pH might be a little bit different, where hydrology might be a little bit different, and that's where these little ecological niches occur. And it's hard for me to wrap my brain around because it's so small and it's constantly changing. Like this idea that the microbes in your soil are always changing, I think is really, really important, because when we start getting into these like general thoughts of like fungal to bacteria ratio or, overall biomass, if my soil is always changing, how can we use those metrics to really make informed decisions, just due to the variability and fluctuation of it?